Hi guys, welcome you all to my channel Explore Edu to Teach.
So today we'll be learning another important concept, another kind of ADC called as the counter type of ADC. Already the flash kind of ADC, the successive approximation register kind of ADC is been uploaded on my YouTube channel Digital Electronics playlist, so you can go and watch it from there. This class will be talking about counter type of ADC, the diagram of it, which is very important, the explanation, how does it work, and then the advantage and disadvantage of the same. So let's understand what is a counter type of ADC. So if you see the components in the diagram of a counter type of ADC is that we have a comparator, we have a AND gate which has two inputs, the clock and the output of the comparator. The output of the AND gate is given to a up counter. The up counter will start incrementing from 0, 0, 0, 0 to the upward manner. Then a DAC will convert the digital to analog, and the comparator will have two inputs, as I said, the analog input voltage which has to be converted into the digital output voltage, and the output of a DAC which is compared, and accordingly a output VO1 is given. So how does this work? We'll try to understand. So initially, since it's a up counter, we'll reset the values of all the bits A3, A2, A1, A0 as 0, 0, 0, 0. Now as you say the up counter starts incrementing from 0, 0, 0, 0 to 0, 0, 0, 1, 0, 0, 1, 0 till 1, 1, 1, 1. That is very important. So you have a up counter which is reset to 0, 0, 0, 0 and it starts incrementing from 0, 0, 0, 0 to 4 times 1, 1, 1, 1, 1. Now this input which is given to a DAC, the DAC converts this digital input into analog output, that is my V0. Okay, so the digital input is converted into the analog output V0, and now what happens is that this input analog voltage is compared to the output voltage. So now again the working becomes similar to that of your SAR, the successive approximation kind of register ADC, in which if my V input is greater than V out, my V0 becomes 1. It's a comparator. However, if my inverting terminal, that is my V0, becomes greater than my Vi, that is my non-inverting terminal, then my V0 1 becomes equal to 0. So if you look over here, if your Vi is greater than V0, my V0 1 is equal to 1, and if my Vi is smaller than V0, my V0 1 becomes equal to 0. So let's consider first, my Vi is greater than V0. So if my Vi is greater than V0, my V0 1 is equal to 1. As I said, if my Vi is greater than V0, my V0 1 is equal to 1. Now if you see, V0 1 is 1, the clock is considered to be 1. Since it's the AND gate, if both inputs are 1 and 1, the output is also equal to 1. And hence it is given to the up counter, and the counter gets incremented by 1. That is, it will be 0, 0, 0, 1. Similarly, if my V input is smaller than V0, then my V0 1 becomes 0. Now 1 and 0 will be giving a 0, and my counter will stop incrementing at that point. So the point at which my A3, A2, A1, A0 gives the output as 0 to the up counter is the, I can say, the digital output for my input analog voltage. I hope I'm very clear. The notes are present in the description box as well. You can go and download it from there. Also, if you see this diagram and the short formula videos and everything is uploaded on my Instagram page as well. The links are given down in the description box. It can help you really in your time of your examination for quick revision and for all the logic diagrams at one particular platform. So you can check on Instagram and follow me over there as well. So what is the disadvantage? If you see now, in case of your flash type of ADC, only one clock was required. In case of successive approximation kind of ADC, it was just n into t clock, so the number of bits into t clock. But here the conversion will take a little longer time, that is 2 raised to n minus 1 into t clock. A little slower conversion, but it has its own advantages as well. The immunity to noise is better. As you learned in the last class, The successive approximation kind of register ADC has immunity which is very low to noise, but here the immunity to noise is very high. So I hope I am very clear with this. If you like this video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram as well. Thank you so much guys. God bless.